Hello everyone, my name is Gutu Çağlayan. I'm from Industrial Engineering Department and this is my freshman year in Bilkent University. Today I will talk about my Physics 102 experiment, a electromagnetic braking of a falling magnet in a coil. Main object of my experiment is that to see a falling magnet affecting by induced current by Lenz's law. And by that we will calculate the braking ratios of the open and short circuits. We will release the magnets from a fixed height and calculate the results by using videos. In the videos, we will look at the frames and calculate our data by the frames of the videos. For my experiment setup, I use an experimental stand and I connect it with a ruler by a tape. Then I connect the coils with the stand. Since it is really hard to understand the frames because my coil neither strong nor bigger enough, I connect two coils with each other and use two power supplies for making the current stronger. I release the magnet for 5 times to have a stronger data from a fixed height for both open and short circuits. I also determine the velocity of the magnet in both circumstances. Here we can see the results of the experiment for both open circuit and short circuit conditions. In the open circuit graph, the trace time are lower and relatively constant across the trials, ranging approximately between 0.018 and 0.021 seconds. In contrast, in the short circuit graph, trace times are clearly higher, ranging between 0.023 and 0.026 seconds. This difference indicates that the magnet takes longer to pass through the coil when the circuit is closed, due to the induced current creating a magnetic field that opposes its motion in accordance with Lenz's law. When comparing the average values, the transit time increases from 0.0194 seconds to 0.0244 seconds, and the calculated braking ratio of 1.26, which is greater than 1, confirms the presence of the electromagnetic braking, although there are small variations between trials in both graphs, corresponding to an approximate error range of about 5 to 8%. This can be attributed to uncertainties in selecting the exact exit frames from the video, slight misalignment of the magnet, and limitation in video resolution. Despite these minor errors, the overall trend remains clear and constant, strongly supporting the theoretical expectations. In conclusion, the experiment clearly demonstrates electromagnetic braking as the magnet took longer to pass through the coil in the short circuit condition compared to the open circuit. The braking ratio greater than 1 confirms this effect and supports Lenz's law. The results are consistent with the theoretical equations given in the report, particularly Faraday's law equation 1, which explains the induced EMF due to changing magnetic flux, Ohm's law equation 4, which relates the induced current to the EMF, and the definition of the braking ratio, which quantifies the difference between two conditions.